Welcome to No Diagnostic Required, the companion show to the C++ Annotated newsletter. This is episode 1, which is of course the second episode, and we've got another batch of news from the C++ community to cover. So I'm Phil Nash, developer advocate at JetBrains, and I'm joined by my co-host Anastasia Kezakova, product marketing manager for C++ tools at JetBrains. Anastasia, how's your 2020 been?
Could be much better.
Yeah, well, I think most of us could agree with that, especially if you're listening to this in real time. So let's rephrase. Since this is the December edition, how's your Christmas been?
In Russia, we do celebrate the Orthodox Christmas, which is in January. So we have the New Year first. So we're preparing for the New Year a little bit. But I did have some celebration on the 25th of December, which was actually my birthday. So I was celebrating some birthday.
Well, happy birthday.
Thanks.
I've got a birthday tomorrow, actually. My daughter has a birthday on the 29th. I've got two sons who had a birthday on the 21st. So it does seem to be the season for birthdays and celebrations. So maybe a more positive turn of events. Let's hope that the next year is going to be a bit better all round. But while we're still stuck in 2020, 2020 has had some interesting news in the C++ world, and in particular, it's been a year of 20s all round, starting with 20 years of LLVM. Do you want to tell us about that?
Yeah, actually, that's great news. So that this year, December 14, actually LLVM turned 20, which is like a surprisingly huge number of years for LLVM, and I was really surprised to see that. Actually, funny fact I noticed is that JetBrains has also turned 20 this year, so actually the same age as LLVM. And when I think about LLVM, I usually first started thinking about Clang and how they do compete with GCC and benefit both from this competition in terms of the features, the language support. So which is kind of nice to see that there's like 20 years of this thing. But actually, LLVM is much more than a compiler. So there is LLVM core, which is probably the most important thing. And there is a Twitter thread where the people do celebrate the 20 years of LLVM and sharing their how they got acknowledged with the LLVM. And it's very interesting to see that most of the people actually first learned about LLVM when they were trying to do a backend for their any custom compiler, any language they are doing, and using LLVM core as a backend. And that's great stuff. There are so many nice and interesting languages mentioned there, actually. And we also do LLVM backend for Kotlin native. So we also do rely on that. And that's probably a very typical thing. And that's a nice backend, which is capable of many, many things. I don't know. Have you ever tried to write a language with a backend on LLVM, Phil?
I've not, at least not directly. But interestingly, a few years ago, in a previous job, when I used to have a real job, I was actually working on a pseudo-reflection system, sort of using macros and templates and things. You can imagine the sort of thing. So I had to come up with some sort of hierarchy of types and annotations. And while I was working on this, a bit later I actually saw LLVM's object model for its parser. And all the similar concepts seemed to be expressed in almost an identical way to what I'd come up with. And I'm still not sure if that's a good thing, but there it is.
And if our listeners have any story, you could share it actually with Celebrate LLVM tag, and I guess LLVM people will be happy to read for it. So there are many interesting stories in Twitter. So with the tag, so just go on and write your own there. And LLVM is not just the LLVM core as a backend, and not just the Clang compiler or the tools we're using, Clang Tidy, Clang Format. Not the real standard in C++, but kind of. And that's really great. We're missing the standard tools in the ecosystem. So also debugger and various libraries. And just recently, we found out a very interesting thing that if you're on Windows, so you probably know that if you take the Clang from LLVM repo, so it will be built with the Microsoft Visual C++ compiler, which means it will be built. We'll be using the built-in macros and the include search paths from Microsoft ecosystem. And if you don't want that, there is a workaround right now. So you can actually take the Clang from MSys2 and use it with the MinGW. So if you want to avoid the dependencies on the Microsoft stuff, so which is a nice way we're kind of using it right now on our own So to build the Clang daemon, we're using in CLion. So we've even written the blog post on that, so you can check the details if you're interested in doing that. But yeah, that's just a nice fact I learned recently.
Yeah, that is one thing that I missed in that previous job I was telling you about. I was looking at what LLVM could do, and I was thinking it'd be great if we could just use LLVM to generate all this metadata for us instead of having to write it in macros. But at the time, I think getting LLVM to build on Windows was possible, but it was a big task in its own right. So we're in a much better place these days. So I'm pretty pleased about that.
Yeah, exactly.
So talking of 20s, the story continues with C++ 20, of course, which was published finally just this month. And it's one of those things that, the same thing happened with C++ 17. Now that we have podcasts telling us about these things in real time, it's like C++ 17 is here. And then a few months later, and now C++ 17 is really here. And now a few months later, and now it's really, really here. So we seem to have had this news a few times, and it's because you get 3 stages. You get when it was sort of finally ratified by the committee, which actually happened back in Prague right at the beginning of this year. And then later, it's gone through all the review process by the national bodies and finally gets signed off by all members of the committee and gets pushed to ISO itself. And then finally they check that all the paperwork's been done correctly and publish it as a standard. And that's now what's happened. So C++ 20 is now an official standard, even though the work was actually all finished quite some time ago.
Yeah, and you can now buy it.
Yeah, absolutely. Yeah.
Do you plan to buy standard, or are you fine with the draft?
I'm fine with the draft. I say that. I haven't read the draft, so...
Okay.
I actually find, funnily enough, since I've been following the committee itself, I find that reading the papers that go into the committee are more readable than the standard itself, because they haven't gone through the process of being written in standardese just yet so much. They're more written to appeal to other programmers. The downside, though, is if you're following a particular feature, like I spent a lot of time following coroutines, for example, and there were so many different slight variations on it that you start to get confused. Which is the one that's actually going in now? And
yeah, exactly.
That thing that I looked into deeply, did that actually make it in? So there's a positive side and a negative side to that. But
yeah, True, yeah. And actually, C++ 20 is packed with so many things, and everyone who's looking at it are so excited. And I remember there was a nice thread on Reddit a year ago, I guess, when they were discussing what are the most excited things about the C++ 20. I guess most of the people were mentioning modulus, and quite a lot were mentioning concepts and coroutines, all the big threes. But also there are things like freeway comparison operator and feature test macros, which are great, or no unique address attribute, which is also great, and many other great things. But if you go deeper into the list and you start thinking about it, the next question you have is when the things are going to be delivered in my compiler, which is probably the most important one right now. But it's good to see at the comparison table of the how the compiler implements the C++ 20, and you'll see many things delivered there, or they're gonna be delivered quite soon. Like we talked last time about the GCC 11 and the modulus support, which they just announced there, and MSVC, which announced some kind of at least partial support for modulus. So, and it's good to see that the concepts are more or less there, with some things not yet delivered, but mostly they're in general there, and all other things are partially there at least, or some of them are fully there, which is great, because that means that you can actually not just look at the C++ 20, or buy the standard or read the draft, but actually use it, which is probably the most important thing. So we'll see how the adoption will go. So we'll run the surveys and we'll see if the people actually are adopting the C++ 20. Maybe not in 2021. I don't believe the majority will adopt it in 2021, but maybe year after year it will come to the biggest standard so far these days.
Oh yeah, the C++ 20 is a big release. Many are saying it's the biggest release since C++ 98 or released 11. I think possibly even bigger than that. I remember when C++ 98 was first published. To some extent, it was really just standardizing what we already had. But all the little details turn out to be quite tricky to implement. And it was years before we had compilers that implemented all of it. In fact, I think there was only ever one compiler that ever implemented all of it. and nobody ever used that one. So we're in a much better position now even with
Yeah,
C++
true.
20 than we were back then, despite it being such a big release. So yeah, I'm excited.
That's true. Do you use, by the way, C++ 20 in Catch too?
No, not yet. I should qualify that by saying I've not been like an active developer on the Catch codebase for a year or two now, so maybe something slipped in. But as I understand it, it still only promises to support C++ 11, as in if you've got a C++ 11 only compiler, it should still work. Well, we did talk about even a year or two ago whether we should move to 14, and there were some nice things that could clean up some of the internals a bit, but it didn't really seem to be worth it for the sake of bringing everyone over to 14. So, the next question would be 17. There's a few nice things there. In particular, we've got like a complete implementation of optional and some other C++ 17 features we've had to sort of backfill. So that would be nice, but still not quite sure if it's that worth it. But 20, I think, would finally give us some really substantial new features to build a framework around, particularly ranges, which would interact very well, I think, with generators, and coroutines as well, which I think could work with generators, but even just with the general test case mechanism could actually be re-implemented in terms of coroutines. So I've been thinking about that, but there's nothing actively going on in Catch at the moment in that respect. But if you want to see what a test framework looks like that's been built from the ground up on top of C++ 20, you should look at Boost Experimental UT by Chris Jusiak, because he's taken all the ideas that I had and run with them.
Yeah, cool. I'm just wondering if there are any modern open source projects utilizing C++ 20 these days. I've heard at one of the recent CPP casts that Andreas Klink in Serenity OS, they're kind of using C++ 20, not really utilizing the features yet, but planning to start and actually announcing that they're with C++ 20. So I'm just wondering, who are those brave people who are already with C++ 20, even with some kind of partial compiler support? So it would be interesting to see more projects in this field, definitely.
Yeah, I suspect we'll see in the near future, we'll start to see new projects starting on C++ 20, but it'll be a bit longer before existing projects, especially those that have a large following already, actually move over, because it's going to cut off so many people, at least in the short term.
Yeah, indeed.
Okay, so sticking with the 20s, we've got yet another one, and that's a blog post from the ReSharper C++ blog, C++ 20 comparisons in ReSharper C++ 2020.3. So you get 3 20s for the price of one in that title. So do you want to tell us about this one?
Yeah, that's a blog post written by the developer from the ReSharper C++ team. And actually, the interesting stuff is that it's kind of mostly dedicated to the reasoning behind the comparison changes in general, like why do we need them, why do we have them, and which problem they actually address. Because sometimes it's not very clear to the developers why we do need this fancy spaceship operator, which is fancy on its own, but also it brings lots of value, because before that we lived in the world when we had 2 quality operators and 4 relational operators, and the CPP core guidelines, they're saying to us that if you implement one, you should implement actually all 6. And if you do compare different types, then the number is growing. And so you have to implement all of them. You could use some, generation feature, which we do have in ReSharper C++ to help you with some things. But anyway, it's just a boilerplate code you're either generating or implementing on your own, which is maybe not good. So the spaceship operator actually makes the task quite easy. It's like a single operator, and with the quality operator and spaceship operator, you can that's all you need actually. So just these 2. You actually even can live with just one, the spaceship, but if you think more about the performance. So performance-wise, it's probably better to use both, because for some types, for some cases, the quality might work faster than the implementation for the spaceship, because if you, for example, have a container class, the quality could return actually if the sizes don't match while the spaceship will do some extra work here. So yeah, performance-wise, you'd better take 2, and you can go with them and implement all the stuff you need for them. And the you can actually rewrite the comparisons in a very nice thing, because the spaceship, it actually returns, this type comparable with 0. So you can rewrite the comparison in a very nice way when you're just comparing with the 0. And so there are lots of good stuff how you can improve your code and remove the kind of, not the boilerplate code, but the code which probably you don't really need. So, and you can make the code easier and more lightweight. So, and it's really great. So the blog post is actually covering that in detail, so you can go through the examples Igor is talking there about, so they're really nice. But the blog post is also talking about the ReSharper C++ support. So in 2020.3, Igor actually dedicated the whole release cycle mostly to that thing. So he did a great job of supporting the new comparison workflow in ReSharper C++. So it just like you can create operator from usages. It was there before, but it now takes into account the spaceship opportunities, and it also can add, like, for example, the missing compare header for you, or like deal with the implicitly generated equality cases or defaulted comparison operators, and suggest all the various checks to help you make your code accurate enough. So yeah, I just recommend you go through it and check the blog post for details if you're interested. So, but yeah, the C++20 comparison, the spaceship is not just a fancy operator. I like the name, actually. I don't know. How do you feel about the name?
It landed well with me.
Yeah. Indeed. So, and I actually have, you probably don't see it, but I have a spaceship on my t-shirt, which is not the spaceship operator, but the Core Heart conference, a C++ one. But yeah, spaceship looks nice and sounds nice, and which is more important, it does a great job for C++ comparisons.
So we often hear that we should write code correct first, and then only once we've profiled, then go and optimize the bits that we need to. With the spaceship operator, the great thing is the bit that we have to write correct first is all pretty much done for us. It's great not to have to write any code and then only have to write code where we have to optimize. So it's just for that reason alone, I think it's a great way forward.
Yeah, I like that for it. It's great not to write any code.
Yeah.
You don't make mistakes.
What is it?
Yeah.
No code has less bugs than no code.
Yeah, true.
So we're done with the 20s for now, but Boost moves on. There's been a new release, version 1.75. Do you want to tell us about this?
Yeah, somehow it's not 20. Surprisingly, I would expect some kind of a 20 release there. But there is this fancy story mentioned in the known issues on the page that the Boost operators in 175 is actually incompatible with C++20 exactly because of the comparison changes, which is a funny thing. Yeah, but seriously speaking, as I used to think about the Boost, maybe it's not that true these days, but as I used to think about it for a while, is that the Boost is kind of playground for the future C++ changes. So when I look at the Boost release, I immediately start thinking about what's coming to C++ in the next 1 or 2 releases. So, and because of that, it's interesting to see that there are 3 new libraries entered Boost in 175. One is the JSON, like parsing and serialization in C++11. Nice library. So it doesn't have any Boost dependency, so it could be used as a header only, which is fine. Without Boost, I guess it requires the C++17, but still it's very nice thing. There is also Leaf, which is an error handling library for C++11. Again, it's no Boost dependencies and it's header only. And there is this concept of the transport of arbitrary error types is independent of a call stack depth, which make a huge improvement to performance. So there is this use case in mind that the callers of the function, they actually don't handle the error, but just forward it. So that's why this performance thing. But I'm more interested in how Leaf is actually related to the recent proposal by Herb Sutter and the team about the error handling. Do you know something about that, Phil? Because I know you were contributing to the proposal.
Yeah, so you're talking about P0709. Nowadays, mostly called static exceptions, which I believe is still going through the standardization process. When I was in Prague, they were starting to talk about it in anger. I mean, literally in anger. got to its first sort of meeting some resistance, and there's been a lot on the mailing list since then. But as far as I know, that's still going ahead, still working its way through, and that is a new form of error handling that looks very similar to the exceptions that we have today, but is implemented much more like ADT-based error handling, where you sequence your code together using basically monads, but it sort of hides all the monadic stuff from you, so it looks more like exceptions. And I still believe that is the way forward for exceptions, for error handling in C++. We'll see if we actually get there. But around the time that I first started talking about that, about 2 or 3 years ago now, somebody pointed me at this Leaf library before it was accepted into Boost. And it looked really interesting because it solved most of the same problems that were making us question whether we should be using exceptions, particularly the performance and determinism aspects that the people in real-time and embedded systems were particularly thinking about. And one of the reasons that it does that is because when you start off a series of calls, you reserve on the stack, or at least the library reserves on the stack, room for all possible error types that are going to be handled, because it knows which ones you can handle at the call site, even if it doesn't know which ones are going to be thrown or returned. And then the actual propagation of errors is still done through something more like error codes, so coming down the stack that way, but very lightweight. And it's only when you actually need to consult the error info itself that you look at where that object is being written to in the stack, which I know at one point, I'm not sure if it's still the case after the Boost review, was accessed via thread local storage. I think there were pointers in there. I'm not quite sure how the mechanism works now. But certainly there's a way of then looking at that information in the stack, rather than it having to be allocated on the heap, as it is with exceptions, and then looked up using RTTI. And that's where all the non-determinism and performance implications come from. So that's pretty good. And you get most of the same benefits of having a lightweight object passed down the stack, which is what P0709 gives you as well. But still, it's a library, and a library for dealing with something as intrusive as error handling means that you're still going to see it. It still gives you a fair bit of extra boilerplate as you propagate these things around. It's pretty good because a lot of it gets pushed off to this. Let's say it used to at least be for local storage, but you still pay a bit of a cost there. So I would still much prefer to see something baked into the language for handling something so fundamental as error handling. But certainly right now, if you're looking at alternate error handling approaches, particularly if you're feeling the pain of exceptions in terms of performance and determinism, then you should seriously look at Boost Leaf. Having been through the Boost review process, I'm sure any issues that were there before will have been ironed out, because it's quite an intense process. So definitely worth a look at if you haven't looked at it already, but I'm still hoping for P0709.
Yeah, I think that's one of the most interesting part for the Boost release. So there are also this PFR library, which is the library for reflection by Anthony Peluhit. So I think we've heard quite a lot about it from Anthony, because he's kind of very active in the Russian community, the C++ one I'm in. So, but yeah, it's a nice library, like C++ 14 reflection library, again, like no Boost dependencies and header only. And the great thing is that you get actually access to members by index, or you get the methods to visit each field of the structure, and like ampersand functions and hashes, and all of this without like macros and boilerplate code, which is great, because if you think about the reflection, quite often you get into macros or something like that, like Unreal Engine, which is a great game developer engine thing, but it actually implements reflection via macros, and in particular via line macros, which are kind of awful. So I hate that. So you get into all of the problems with the macroses there. So macros-based implementation are, to my extent, the most awful ones. So it's great to see that there is a library you can use right now. So if you want to do some reflection, you can already try. So it's maybe not not giving you the full power of the reflection, just some basic stuff, but it's already enough for quite many tasks, and you'll get that without all these boilerplate code, which is nice. So it's nice to see that it's in Boost actually. So yeah, these are the free libraries. There are also some updates to other libraries back to the release, that you can go to the Boost page and learn about them in details.
Great. So another boost release to look at.
Yeah.
That's sort of the end of the pure technology part of material. There's a bit of community news. So podcasts, first of all. The last episode, as well as launching our own podcast, we mentioned two others in the community that are just launched as well, TLB Hit and ADSP. But since then, we've had yet another one, to his complement. And this is not strictly a C++ podcast. I think it's mostly about games programming, actually. But I thought it's worth mentioning because one of the hosts is Matt Godbolt, who, of course, is very well known in the community, particularly for Compiler Explorer. So it's Matt and Ben Rady talking about programming, perhaps particularly games programming. And they've had one episode so far, of course, episode 0, talking about their history together and individually their career development, how they've got to where they are today. So definitely worth adding that to your podcast queue, which by now I'm sure is overflowing. So I do wonder if this sudden proliferation of podcasts in the C++ community has come about because we've all been stuck at home for so long. But we'll see whether that continues. If we get a new podcast every month, we could be in for an interesting 2021. But talking of podcasts, we were mentioned in last week's CPP cast, the first podcast for C++ programmers, who mentioned our inaugural episode. And I believe Jason did ask what our frequency was going to be, because CPP cast, of course, is weekly, almost every week. We're going to be monthly, just to settle that one. So this is the December 2020 edition. We last had the November edition, and we will continue monthly from now on. That's the idea. And I believe you just wanted us to say hi to Jason.
Yeah, I think we should say hi to Jason because he actually said hi to me in this episode of CPPcast talking about this Trinity OS. I guess it was like a little bit less than a couple of weeks ago, a week and a half probably. So yeah, hi Jason. Actually, it would be a little bit hard to chat that way because they're kind of weekly, they're monthly, so the chat won't be very nice. So probably we should find another way of chatting.
Yeah, it could be like one of those sci-fi films where people have to have this async conversation across multiple light years and wait weeks for the answers.
Yep. Yeah. Let's see if we get the answer.
And some more community news. Again, just as there are now so many podcasts in the C++ world, we have, it seems, plenty of conferences, but there is one more. So why another C++ conference? This one is a little bit different. It's been created by Jean-Yves Menide, and he's particularly putting a focus on inclusion and diversity. And if you know Jean-Yves Menide, probably give you an idea why he's been very central in the community trying to promote those things. And he is himself from an underrepresented minority. But also just on the pure technical side, he noticed that there wasn't really any conferences for C programmers. And so he's wanted to make this a systems programming conference rather than a C++ conference. So as well as C++ and C, he's looking at Rust and even Lua and other languages that would call themselves a system programming language. So it's a system programming language, but with a particular emphasis on inclusion and diversity. And I think that can only be a good thing. So good luck to John Heed with that.
Yeah, good luck. Great initiative, actually. I think I was definitely missing the pure C conference in the past when I was mostly doing the C, but I think it would be good now as well because there are so many people who are interested in like kind of native development. And so they would love to learn a lot about what's going on there in C, not just, come into the C and C++ conferences and learning mostly about C++. So yeah, that's great. That's interesting. So, but yeah, I feel like I'm missing conferences a lot.
Yep. Yeah, it's going to be interesting to see how 2021 unfolds, particularly later in the year as vaccines and things come into play. We're not going to discuss that so much, but I am hopeful that the impact on our community is going to be a positive one. So we'll keep you informed as that develops.
Let's hope for the best.
Yeah. And finally, well, almost finally, I think we've got two more things, but This was an interview question on Reddit that somebody brought up. Maybe you want to take us through this one, Anastasia?
Yeah, I just run into this nice Reddit thread and discussing this example, which someone got from on an interview. So, and there was like that simple question, what we'll see in the terminal after we run this code. And there was a very interesting discussion. So, like, first of all, yeah, there was a discussion if we're indeed dereferencing the null. So, which actually is the case. And there like leads to undefined behavior. And that's actually the short answer. So like, yeah, you got the undefined behavior. So you got whatever you can get here. So there are no right answer probably here with UB. But despite the fact that like no guarantees because of the UB are coming from the standards, still there are lots of things which might happen in the real compilers, and there is a very nice discussion in the thread about what actually is coming there in the compilers. And from this thread, I actually learned from the Microsoft compiler flag for exception handling model, which actually allows you to specify the exception handling model supported, and the arguments. They actually specify whether to apply catch syntax to like both structured and standard C++ exceptions. So, which is nice. So you can actually get the exception caught here, or you can get the segmentation fault. And yeah, in general, the right answer is we don't know what we get. And that's probably the typical answer in C++. But yeah, with the compilers, you can still do something and try to control the behavior, which gives you a little bit of a hope here.
So as so often happens, there is a simple answer, which is we don't know. And there's the C++ community answer, which is a sprawling mass of multiple layers of well, actually.
Yeah, it actually was interesting to see that many people were just giving example a try, and they say like, okay, so I got this, and then I got this, and the answers were different. So which proves that, yeah, there is indeed an undefined behavior. But then it's a very interesting discussion on what you could get with the compilers and what are the compilers guarantees, which are the real world guarantees, not the standard guarantees. And fortunately or unfortunately, in the modern C++, we often get these things kind of different, at least a little bit. So maybe with UB, it's kind of fortunate behavior. I don't know, Phil, have you got any tricky questions in the interview in your life? The one you remember?
There was definitely one time that I got caught out by a question. And it was only afterwards I went off and read up on it, and I realized that it was one of those questions where the interviewer was not really asking for a specific answer. They just wanted to know which books you'd read. And if I remember right, some years ago, if I remember rightly, it was, don't remember the full question, but it involved virtual constructors. And so most programmers' immediate response was, we can't make a constructor virtual. But that wasn't the answer they were looking for. They wanted to know if you'd read Scott Mayer's books, which were fairly new at the time, where he talks about virtual constructors as a pattern, which we might think of as the factory method these days, before we called it that. And I hadn't quite read the book at that time. So, yeah, I'm never quite sure if that's a good interview technique or not, but I do remember that sticking out.
Yeah, I remember I was trapping people on my own when I was working in the Yotta company, when we were doing like the 4G networks development, various like networking congestion systems. And I was regularly asking the people who are coming to the interview, what's the difference between the TCP and IP? And, that's a real trap, because usually they are expecting the question about what's the difference between the TCP and UDP. And when I ask about the TCP and IP, and they're like, okay. And they start thinking, and some answers were really surprising. Some of them were like good enough, so the person starts thinking about the layers and like, yeah, these are from the different layers. That was okay. But quite often we get a whole bunch of very funny answers that we were keeping inside the team as nice jokes afterwards. But yeah. So sometimes you can trap with an easy question, actually, not getting into the, undefined behavior in C++.
I could tell you a joke about UDP, but you might not get it.
Yep.
The old ones are the best, eh?
Yeah, I like it.
So there was one more thing that we wanted to talk about. We had an AMA Ask Me Anything session on Reddit for CLion. a couple of weeks ago now, wasn't it?
Yeah, it was just a couple of weeks ago. We locked the thread already, but you still can read through it. So I actually would like to say that I first would like to thank Rob Irving. You probably know him as a host of the CPP cast for doing a great job as a CPP subreddit moderator who was helping us with the AMA session. So thank you, Rob, really for all your assistance. So we tried the AMA format in the way of the webinar in May, I think, in 2020. That was nice and we really like it. But after that, we decided that maybe we have to try something new. So we decided to try Reddit. And so we actually loved that a lot. So we've got maybe 35 questions, but there were huge discussions under each one. So we've run into various discussions. There were like 7 people from the team answering and a few more behind the scene helping us with the answers. So that was nice. The thing that surprised me is that we got lots of questions on the 2 particular project models. And you could probably guess, but that was not the CMake or Make files, which are kind of popular these days, but that was Mason and Basil. And if I look at the results of the, for example, developer ecosystem research we do, I see that the Basil is something about 3%. And it's growing because the Google is kind of pushing it. And I know some companies, big companies who are using Basil and relying on it a lot, not only in the C++ area, actually. So it's not just for C++. And also Mason is kind of also not that big. So in our research it's inside the less than 4% for all the rest. So I even don't know the exact percent. I think it's kind of small. So, but still the people were asking about it. I looked after that. I was looking at the Mason side. I was looking at the projects which do work for Mason. I was surprised that I've seen kind of lots of known projects. So I'm just wondering why these 2 in particular are of interest to the readers. They're on Reddit, so if there is something in them we should learn about or know more about. Because before that, I was mostly pinged about the SCons, probably because of the Russell Winter, who is constantly asking me about the SCon support in CLion. But also, I think it's used, if I'm not mistaken, in Godot. So the people from using the Godot are also asking about the SCon support. So I'm not sure what the case for Mason and Basil here is. So yeah, it would be interesting to know more how the people are using this. So if you do use these project models, just do leave a comment on the project if that's open source, or just describe why are you selecting the one of these 2. So probably with Basil it's more obvious, but with Mason I really interested why do you use that? So what's the benefits it brings to your project? So it would be interesting to learn more. And another thing which actually attracted my attention was the interest in debugger feature, but not the standard question about the debugger feature, maybe because we covered a lot in the recent release, but it was about the cross debuggers, the cross debugger for Python/C++ and Java/C++. So that was really interesting because I'm wondering what are the projects which are mixing this language in the way that they need these cross debuggers. So obviously there's Android NDK, which you can think of first if you think about the Java/C++, maybe Python or something like TensorFlow in terms of Python/C++, but I don't know more. So if you have nice cases in your projects, just please share with us, because I'm really wondering what are the cases for this cross debugger. I don't know, Phil, have you ever used any kind of this cross debugger thing? So in what cases, what were the languages, and what were the case if you do?
I've mostly used them going from C++ to and from C#, or perhaps back in the day VB as well.
Oh, okay.
But C# was quite popular, both through C++ CLI or through pinvoke interfaces. Each have their own idiosyncrasies, of course. But in terms of Python and C++, I know that's got very popular in finance and the banking world in general, because Python, a great, obviously high-level language for instrumenting things, but a lot of the heavy lifting done in C++, for the same reasons that in ML you have the same sort of pattern as well.
Yeah, you will probably interop into pure C in case of any performance critical task from many other languages like Python, or I know Go developers also do that quite often. So probably in that case, you indeed might need a cross debugger, which might be an interesting stuff. And yeah, like I would say that we even tried that, so we had a student in the past who did this prototype for the cross debugger. So it was a funny thing to work on, I guess, to work at. And so we looked at this prototype. It was interesting and nice. I don't think we ever made it to the production level. So maybe we should, if there is really this kind of an interest. So I was kind of surprised to see that questions in the session. But yeah, thank you everyone for your questions. It was nice thing, and I especially like the question you Phil answered there. So maybe you can talk about that.
Yeah, quite proud of my contribution to this thread. So somebody thought they were being clever by asking, what's 1 + 1? So of course my engineer's answer is it depends. Depends on the definitions of 1, or what definitions of 1 are in scope, or in the same namespace as the plus operator, and as well as how or whether the plus operator is overloaded. So yeah, that's C++ for you, I'm afraid.
Yeah, that's a very good C++ answer in a C++ dedicated thread.
Okay, well, that's all the material that we've got to cover for this episode, and that means for the rest of this year. So we will be back with more C++ news in the new year. There'll be a January edition. As I said, we're going to be monthly moving forwards. So if you have anything you particularly want to see covered, you should let us know. We'll try and put some contact details up on the website so you can reach us there if you don't already know how to reach us. Let's make this more of an interactive thing as well, I think.
Yeah, indeed. So let us know.
So I suppose that just leaves us to wish everybody a happy new year, whatever that means for you, and I hope that the next one is going to be a better one all round.
Yeah, happy holidays. Yeah.
Bye, everyone.
Bye.